Hey, good afternoon everyone and welcome again to subject natin, Engineering Mechanics. And for today's lecture, we will be discussing the basic concept and general principles being used sa subject natin Engineering Mechanics. No? As per our syllabus or our course outline, we should have discussed this by last week pa. Unfortunately, yun nga, nagkameron ng nawalan ako ng boses. Kaya I opt to continue the discussion of the basic concept and general principles today so that we can continue with our timeline with the subject. Okay? So our lesson outline for today are as follows. So we will have an introduction about mechanics. We will discuss the fundamental concepts used in mechanics. Of course, including also yung units of measurement na consider natin. Discuss also yung international system of units na ginagamit worldwide. Numerical calculations considerations, and also yung general procedure natin for analysis when dealing with problems in engineering mechanics. Okay? Our lesson outcomes are as follows. Number one is to introduce to you the basic quantities and idealizations of mechanics. Yung mga assumptions, mga ginagawa nating rule no when solving problems in mechanics, to review the principles for applying the SI system of unit, and to solve conversion problems involving the unit system natin, yung two unit system natin later. Okay? So let's start with the introduction of the subject. Okay? So let us first define what is being called as mechanics. Okay? So as per the book by R.C. Hibbeler, mechanics is a branch of physical sciences concerned with the state of rest or motion of bodies that are subjected to the action of forces. So ibig sabihin, when we talked about or when you studied physics, so you already being exposed dun sa sa mechanics kasi you already discussed what is a force, no? And then you applied or you already studied yung iba't ibang kasama sa physics, no? Like for example, yung sa simple pendulum, no? And then yung sa friction, then yung Newton's law of motion, na all of them are related or interconnected and being used when we study mechanics. Okay? So once that we are considering a body na subjected to a force, no? We are actually talking about mechanics now already. Okay? And mechanics has three different branches. Okay? Namely, yung rigid body mechanics, tinatawag natin, deformable body mechanics, and also yung tinatawag nating fluid mechanics. So ano ba yung yung pinakamahalaga sa atin dito? For our subject matter this semester, we will study only yung rigid body mechanics. No? See, this is the basic requirement to sa study ng deformable body mechanics and fluid mechanics. And I think in your curriculum, you also have deformable body mechanics, yung tinatawag natin mechanics of materials, kung iba man yung tawag, o strength of materials dati, no? Yun yung tawag sa kanya dati. And then you also have fluid mechanics. I know the IEs have fluid mechanics, no? And also yung EE. Considering naman yung flow ng body in fluids, no, in liquid or gas, kaya fluid mechanics siya. Pero again, we will just focus on rigid body mechanics. Na this is essential for the design and analysis of many types of structural members, no, for example, for civil, mechanical components, and also electrical devices na na-encounter natin in engineering. So, si rigid body mechanics is divided into two areas na tatawagin natin statics and dynamics. When we say statics, it deals with the equilibrium of bodies either at rest or moving with constant velocity, no? And then we have dynamics na pag-concerned with accelerated motion of bodies naman. So, since itong subject natin is coded as engineering mechanics alone, sabihin dapat ma-discuss natin both statics and dynamics. Unlike sa curriculum nung civil engineering na students, no? Meron kaming subject na statics lang muna. Then, the following semester, meron kaming subject na dynamics lang. Kasi, more focus yun sa pag-decide o pag-solve ng problems involving mga structure natin. Kaya kailangan ng civil yun. Pero for electrical and industrial engineers, you only need to understand the basic concept being used in practice para kapag nasa site na kayo, you know or you are aware what is happening with dun sa surrounding ninyo that nagpapakita ng mechanics, no? Okay, so next is, saan na ba tayo? Okay, so historical development ng mechanics. So the subject of statics developed very early in history because its principles can be formulated simply from measurement of geometry and force, no? For example, yung mga sinulat ni Archimedes, no? Wala sa Archimedes, yung nagpakilala ng principle ng lever, no? So kasama yan doon sa mga early historical evidences na before, kahit hindi pa siya dubbed as statics or as a branch of science, ginagamit na siya dati ng mga sinaunang tao, no? So studies of the pulley, inclined plane, wrench are also recorded in ancient writings na at times very limited primarily to building construction lang yung application niya. Pero now, it is being used on different areas. Kaya kayo as future engineers, you need to be aware on how this principle is being applied in your discipline, no? Since the principle of dynamics depended on accurate measurement of time, this subject developed much later, no? Sabi nila, nung time ni Galileo Galilei, siya yung naging first major contributor do sa field, no? Na siya yung nag-study about pendulum and falling bodies na ginagamit natin. Yung pendulum dapat na cover niyo siya sa physics, no? At least yung mga harmonic motion o yung may spring, okay? Yung back and forth ng spring, yung simple harmonic motion natin and yung falling bodies. And yung pinaka-important contribution in dynamics is given by Isaac Newton, no? Dahil sa formulation niya, yung three fundamental laws of motion na i-discuss natin later on. And then yung tinatawag nating law of universal gravitational attraction between two particles, no? So, with these laws na discover nitong dalawang known scientists, no? May mga important techniques na na-develop na ginagamit such as yung Euler's method, the Lambert method, or Lagrange na later in your studies ma-encounter ninyo in your higher subjects. Okay? Pero ito yung naging basis o yung naging foundation kung paano nag-transcribe dun sa mga much more sophisticated na mga laws na ginagamit natin in engineering. Okay? Next is yung tinatawag natin fundamental concepts. So may tinatawag tayong basic quantities kasi when we are dealing with mechanics, laging may units, laging may unit of measurement or hindi mo siya pwedeng i-describe by numbers alone. You need to quantify it or you need to describe what is being measured, no? And the following four quantities are used throughout our subject. Yung first is yung length. Next is time, mass, and force. Okay? So si length, this is used as to locate yung position of a point in space. And thereby, it describes also the size of the physical system. So kapag describe natin yung length ng isang body, at least nagkakameron tayo ng grasp kung gaano kalaki yung kinoconsider natin. Let's say kung halimbawa mayroon tayong example, may dinidescribe tayong building, pag sinabi natin mga 3 meters yung building, pwede natin i-assume na 1 story lang siya o bungalow style lang siya. Pero once na halimbawa natin mga 10 meters yung building, pwede natin ma-describe o pwede natin ma-assess agad na baka mga 3-story or greater yung height niya kasi ang standard height ng per level is mga 2.7 hanggang 3 meters each, no? So kung meron kang 10 meters, maybe more than 3-story na yung pinag-uusapan natin. So by using yung quantity na length, we are able to grasp yung pinag-uusapan natin kung gaano siya kalaki, no? So once a standard unit of length is defined, one can use it to define distances and geometric properties of a body as multiples of this unit, no? So yun nga, na dinedescribe niya yung laki mismo ng body natin. Next is yung time, no? This is conceived as a succession of events. So although the principles of statics are time independent, or meaning, hindi natin kino-consider si time kapag statics yung pinag-usapan natin kasi we are not kumbaga naka in equilibrium na ano lang siya, no, state na kaya nga static siya. Kung naka-rest siya, it will remain at rest, or if it's moving, it will remain at the same movement or constant velocity. Hindi siya mag-i-increase ng acceleration. Kaya nga hindi siya masyadong napapag-usapan sa statics, pero this quantity plays an important role in the study of dynamics. Kasi once we are dealing with the dynamics na, we consider the change in time kasi it will give us a change in acceleration. And kapag may change in acceleration, mag-iiba yung behavior ng body natin. Okay? The third one is yung mass. So, this is a measure of quantity of matter na pinopossess ng body natin na used to compare the action of one body with that of another. Okay, so siguro mas mas prevalent yung pag pinag-usapan natin yung mass kapag yung pinag-usapan natin mamaya yung gravitational attraction, no? Kasi ano ba? This property manifests itself as a gravitational attraction between two bodies and provides a measure of resistance of matter to change in velocity. Kasi di ba pag babalikan mo yung Newton's law of motion, depende sa mass mo, magiging iba yung tendency ng body mo to resist motion, yung natawag nating inertia, no? So depende sa value ng mass, iba yung magiging behavior, no? Capacity or tendency ng body to resist yung motion natin. Okay? Then last is yung force. So this is considered as a push or pull exerted by one body on another. So nag-exist lang si force kapag may nag-exert sa kanya or may direct contact between one body to another body. Kung this interaction can occur when there is direct contact between the bodies, such as, for example, person pushing on a wall, or it can occur to a distance when the bodies are physically separated. Right? So ano yung ibig sabihin ng mga although physically separated sila pero meron pa din force? So syempre yung mga gravitational force natin, electrical forces, magnetic forces, no? Then yung kahit walang contact, direct contact is nag-exist pa din si force na tinatawag natin. Okay? So in any case, force is completely characterized by yung magnitude niya, direction, and kung paano natin siya ina-apply dun sa body natin. Okay? So yan yung 4 basic quantities natin. Now we go dun sa idealizations na ginagamit natin. Kasi in solving mechanics, it is much more simpler if we can idealize yung object in a simplified manner. And we use models or idealizations to simplify yung application ng theory. So we consider 3 important idealizations. Number 1, o yung first one, is yung pagtatawag natin particle, no? So pag sinabing particle, yung isang body, it has mass, but yung size niya is neglected. So hindi kino-consider yung size niya, no? So when a body is idealized as a particle, the principles of mechanics reduce to a rather simplified form. since the geometry of the body will not be involved in the analysis of the problem. Okay? So ano yung magiging parang example nito, no? Bawa yung size ng Earth, no? So comparing it dun sa orbit ng lahat ng planets, no? Earth can be modeled as a particle, no? And then pag gusto nating alamin yung mga yung motion yung orbital motion ng mga planets, we can neglect yung size niya kasi yung different planets have different sizes, and yung size ng Earth will just be negligible when comparing with the other masses or other heavenly bodies na present dun sa orbit na pinag-uusapan natin. Okay? So, again, when we are talking about particle, yung geometry ng body will not be involved. So yan, naka-emphasize naman yan with the red font. Next is natawag natin rigid body kasi nga rigid body mechanics tayo. So ano ba pag sinabing rigid body? So a rigid body can be considered as a combination of a large number of particles in which all the particles remains at a fixed distance from one another, both before and after applying a load. This model is important because the material properties of any body that is assumed to be rigid will not have to be considered when studying the effects of forces acting on a body. So, ang ibig niyang sabihin, hindi mo na muna kino-consider yung material properties ng body, no? So, kasi yung internal property ng mismong body mo, consider mo siya ay dun sa next na yung sa deformable sa next study yung sa deformable bodies of mechanics, no? Pero for rigid body of mechanics, kung ano yung body mo nung nag-start yung loading, it will be the same, no? So deformation is not yet considered. Okay? And then in most cases, yung actual deformation occurring in structures are relatively small, no? Kaya yung rigid body assumption is suitable for analysis. So, later may example tayo kung paano i-distinguish yung rigid body kay particle, no? Pero basically, it remains at a fixed distance from one another both before and after applying a load. Kasi dapat, di ba, pag nag-apply ka ng load, dapat merong change dun sa shape ng isang body, no? Pero kung rigid body siya, it will not have any change. Mangyayari lang doon is yung effect lang ng force acting on the body. What will happen if a force is being applied to a particular body. Okay? Then last is yung tatawag nating concentrated force. Okay? So a concentrated force represents the effect of loading which is assumed to act at a point on a body. Okay? So represented siya by a single point dun sa system natin. So we can represent a load by a concentrated force provided that the area over which the load is applied is very small compared to the overall size of the body. No? So kung halimbawa yung contact between two surfaces are very small yung one surface to the other, so we can actually create or represent it as a concentrated force to simplify our solution, no? So let's have here yung first picture natin. So yung first photo natin is a picture of a hook, no? So meron tayong hook dito sa A. I'm not sure kung kita, no? Pero may hook dyan sa A dito sa chain natin dito. And meron tayong tatlong chain dito, no? Kung may chains tayo dyan, may tatlo tayong forces na pwedeng nag-act doon sa mismong hook natin. Since these forces are meeting at the same point, yung point A natin, no? So may tensile force tayo dyan kasi may binabanat, meron siyang weight dito, no? So ang tendency niya is ikarga tong weight na to, then dinistribute dito yung weight, tapos itong single chain na to, yung weight na dinadala nitong dalawang chain na to is dinadala niya ng solo. Okay? So we can assume na yung hook represent a particle, no? Kasi yung size na is negligible compared dun sa weight na kino-consider natin. Okay? Also dito sa another picture, so yung meron tayong railway, no? So si rail track is made up of steel na common siya sa engineering material na hindi siya madaling mag-deform, no? Kapag halimbawa in-apply siya ng load. Like for example, pag dinaanan siya ng wheel ng train. Okay? So we can consider yung railroad natin o yung track natin to be a rigid body acted upon by concentrated force of the rail. No? So ibig sabihin, since this is a rigid body, pwede yung contact dun sa surface niya is represented as a concentrated force. Kasi nga, yung railroad wheel is a rigid body, and then yung concentrated force natin is the tail, no? So the contact force between the wheel and the ground. Okay? So, yan lang isa sa mga example ng idealizations natin. Okay? Then now we go to dun sa tatawag natin Newton's three law of motion. So again, this is just a review of your physics. So engineering mechanics is formulated based on Newton's three laws of motion, the validity of which is based on experimental observation. So ito yung first one. So first law, sabi niya, a particle originally at rest or moving in a straight line with constant velocity tends to remain in this state provided that the particle is not subjected to an force. Okay? So as long as walang nag-act na force o walang force net na equals or greater than 0, the body will remain as is, no? Kung halimbawa siya ay nasa table lang, no? Kung wala kang in-apply na push ng force or any other force dun sa mismong body natin, it will not have a change in its state, no? So sinasabi lang sa first law, provided that there will be no unbalanced force o yung pag kinuha mo yung tinatawag natin resultant o summation ng mga forces natin, kapag siya ay equal sa 0, sinasatisfy natin yung first law. Okay? Sabihin walang unbalanced force. Ngayon, pag nagkameron ng unbalanced force, there will be a motion na kapag nagkameron ng unbalanced force. And dito na papasok yun sa second law and sa third law, no? So sa second law, a particle acted by an unbalanced force. So ibig sabihin do sa pag hindi na applicable sa first law, no, nagkameron ng unbalanced force. So ibig sabihin meron ng hindi na opposed na force. So ang tendency is to move from one direction to another. So when unbalanced force F experiences an acceleration A that has the same direction as the force and a magnitude that is directly proportional to the force. So dito papasok yung ating inertia. Okay? So dito na po nakuha yung formula na force is equals to mass times acceleration. Dahil sabi nga, directly proportional to the force yung acceleration natin, and yung ating constant of proportionality, tinatawag nating mass o yung quantity of matter inside a body. Okay? Then yung sa third law natin, we have the mutual forces of action and reaction between two particles are equal, opposite, and collinear. So basically, sinasabi lang niya kung ano yung in-apply ng one body to be able to oppose that force, the other body will exert the same force back to the first body, dun sa unang body natin tinutukoy, no? So meron siyang action reaction. Okay? So yan yung sa three laws of motion. And then we have also the Newton's law of gravitational attraction. So dito, after formulating yung three laws of motion, Newton postulated a law governing the gravitational attraction between two particles, no? Ito ay existing siya kapag outside the Earth yung pinag-uusapan natin. Yung formula niya para dun sa force of gravitation between these particles are given by the formula G times M1 M2 over R squared, wherein yung F natin is yung force of gravitation, G is the universal constant, ang value niya ay 66.73 times 10 to the negative 13 meter cube per kilogram second squared, no? So this is according to experimental evidence. So this is the standard value ng G, no? Para dito. And then yung M1, M2 natin are masses of each particle, no, na kino-consider natin. And then yung R is distance between the two particles. So in the case of a particle located at or near the surface of the Earth, however, only gravitational force having any sizable magnitude ay yung Earth lang and the particle. No? Kapag pinag-uusapan natin is a particle sa Earth or near the Earth, ang nag-exist lang na or ang considerable na particle lang natin is yung body itself and si Earth, no? Kaya dito napunta si weight na tinatawag natin. Will be the only gravitational force present kapag kino-consider natin ang any particle na located at or near sa Earth, no? So paano nangyari si weight, no? Si weight is from the same expression. So dito sa formula natin na F is equals to G M1 M2. Pero we can develop it by substituting yung value ng weight dun sa F, no? So since force si weight, and then yung G natin, so si M1 pwede natin tawagin so si F natin is yung ating weight, si M1 is yung any particle na mass natin, and then when we assume na si M2 is yung mass ng Earth, no? And then yung R is yung distance between the Earth center tsaka yung particle natin. So magiging constant yung value niyan, no? So sabihin natin R. So pag sinubstitute natin sa formula, F is equals to G M1 M2 over R squared. So that is W is equals to G, and then this is M ME over R squared. And then when we look at the notation dito, yung M G ME over R squared, no? So itong quantity na to, nilelet natin siya as G, no? As letter G na maliit to represent yung gravity sa Earth when considering yung at sea level at 45 degrees latitude. Okay? O yung tatawag nating standard location. Kaya makapapansin nyo ang formula ng weight is equals to mass times gravity of acceleration due to Earth, no? Na ang value niyan is 9.81 meter per second squared or 32.2 feet per second squared. Okay? So, yan yung constant niya. So, kapag ang pinag-uusapan nating body is nasa Earth, no? Automatic yung weight niya, ganito na yung formula. You don't need to use this formula anymore kasi we are considering the constant G, no, na ito multiplied by the mass of the Earth and then kung ano yung radius ni Earth. Okay? So, yung yan yung kino-consider natin. Alright? Next is ano ba next? Yan, unit of measurement natin. So yung mga quantities na describe natin earlier are not all dependent from one another. So they are related by Newton's second law of motion, yung F is equals to, yung formula natin na F is equals to M times A. So because of this, the units used to measure these quantities cannot all be selected arbitrarily. So the equality is maintained only if three of the four units called base units are defined and the fourth unit is derived from the equation. So sa system of units natin, we are actually using two, yung International System of Units o yung SI. So ito yung modern version na tawag nating metric system which has received worldwide recognition. Kasi bukod sa USA, every country in the world are using SI system na, no? And then sa US may sarili siya which is called the US Customary Unit, so yung FPS system natin. Okay? So yung table 1-1 presented are the system of units and the different base unit na ginagamit sa kanya depende sa quantity, no? So for SI and then FPS, so pag length ang pinag-uusapan, kay SI meters ang tawag sa kanya, kay US ay foot, no? Or feet kapag plural na siya. Kapag time ang pinag-uusapan, second siya parehas, no? Parehas second yung ginagamit natin. For mass, kay SI system, kilogram yung ginagamit natin. For US is slugs yung unit niya. And si slugs, kaya natin siyang i-derive using yung formula pa rin ni F is equals to mass times acceleration, no? So, kaya yung sa standard location natin for weight. Okay? So, mapapakita natin yan mamaya. And then for force, we have newtons. Pagkatawag natin kilogram meter per second squared or pound kapag US customary. So, ito, mayroon kasing weight na pound, may mass na pound, tsaka may mass na force, no? Pag minsan nilalagyan ng F dito na maliit na subscript, no? Pound force to consider it as a force. Okay? So, pakita muna natin kung paano nakuha si Newton. No? Nakuha si Newton using yung formula na F is equals to mass times acceleration. So, kung SI ang ginagamit natin, okay? So, si force natin is equals kay mass, ang ano ng mass ay kilograms. So, kilogram. Sa acceleration natin, kapag SI is meter per second squared. No? Pag pinag-multiply natin yan, that is kilogram meter per second squared. Okay? So kung 1 unit niyan, ang tawag sa unit na kilogram meter per second squared ay actually Newton yung pangalan niya. Kaya yan yung kanyang equivalent unit. No? So 1 Newton. So pag nakakita kayo ng Newton na unit, ibig sabihin niya is kilogram meter per second squared. So kaya nagkameron ng ganong unit dun sa ilalim na yan. Okay? Then for US, no? Kung paano nakuha yung slugs. Okay? So yung slugs is nakuha din using yung SI natin. So kung FPS system tayo, so si slug is unit ng mass. Okay? So from F is equals to mass times acceleration, this will be M is equals to F over A. So yung force natin, again, is in pounds. No? So bawa 1 pound over yung ating acceleration na 1 foot per second squared. So pag ginawa natin, this will be 1 pound second squared per foot. Okay? Which is ito yung unit na yan. No? Makikita nyo, ito yung unit na yan. So, doon nakuha yan sa formula ng F is equals to mass times acceleration. Okay? Next is yung conversion factors natin. So, I have here another table para magkameron direct conversion between FPS system, yung US system natin, to SI system. So, kung halimbawa, in pounds yung given, pwede natin siya i-convert to SI by using this value, no? So, halimbawa, meron kang 50 pound. Meron kang 50 pound na force, no? Gusto mo siyang i-convert into newtons. So, ang gamitin mo lang is itong nakalagay, no? So, 1 pound, ang ibig sabihin ko sa nito is 1 pound is equals to 4.448 newtons. Ito ay 1 slug is equals to 14.59 kilograms plus 1 foot is equals to 0.3048 meters. Okay? So, kung gusto nating i-change in newton, say 50 pounds, so gagamitin mo itong conversion na to. So, 50 pounds, gawin natin newton. So, para ma-eliminate si pound, kailangan mag-cancel out. So, 1 pound times 4.448 newtons. So, cancel mo to. Matitira ay si newton. So, direct multiply lang. 50 times 4.448, that is equals to 222.4 newton. Okay? So, using these conversion factors, you can actually convert your FPS quantity into a SI quantity. Okay? Also sa FPS system, ang 1 foot is equals to 12 inches. No? Parang ruler lang yan. And then ang 5,280 feet ay equals sa 1 mile. And then ang 1 pound is equals to 1 kip o kilopound. And then ang 2,000 pound ay equals sa 1 pound. 1 ton. Okay? 1 ton. So, ilan yun sa mga basic na conversion factors na dapat alam natin at the back of our heads, no? Okay, next is yung tatawag nating International System of Units, yung SI system natin. So the SI system of units is used extensively since it is intended to become the worldwide standard of measurement. Therefore, presented are some rules for its use and some of its terminology relevant to engineering mechanics. Yung first rule is paggamit ng prefixes. No? When a numerical quantity is either very large or very small, the units used to define its size may be modified by using a prefix. So kung halimbawa masyadong malaki yung value, pwede mo siyang i-change into a a unit na may prefix, no? So ito yung ibig sabihin niya. When we say giga times 10 to the 9, pag mega times 10 to the 6, pag kilo times 10 to the 3, no? So halimbawa, meron tayong 1,000 1,000 newtons, no? Paano siya i-change na may prefix, no? So si kilo is good for 10 raised to 3, no? Ang 10 raised, itong 1,000 natin, pwede siyang i-represent as 1 times 10 to the 3 newtons. So itong 10 to the 3 na to, we can convert it as, yung symbol niya is K, so 1 kN. So ibig sabihin, si 1,000 newton, equal daw pala yan sa 1 kilo newton. Okay? Yun yung ibig sabihin niya. So, halimbawa, meron tayong 250,000 kilonewton. Okay? So, ilang meganewton tayo? Ilang meganewtons meron tayo? Okay? So, si meganewtons ay 10 to the 6, no? Okay? So, meron tayong kilonewtons. So, pwedeng gawin natin, di ba si kilo ay 10 to the 3, no? Kailangan natin ng another 3. So, pwedeng itong tatlong zero na to is 10 to the 3 ulit. So, para maging mega newton, this is, pag pinag-plus natin, this is 10 to the 6, no? So, this is equivalent na sa 250 mega newton. So, yun yung pag-change ng prefix natin. Ang ibig sabihin sa kanya, pag may mega siya doon, that will be mega newton. So, ibig sabihin din niya 250 times 10 to the 6 newton, which is also equivalent nga sa 250,000 kilonewton or equivalent siya sa 250 tapos ilang zero, 6 na zero newton. Okay? So, kung very large yung mismong unit natin or very small, we can use prefixes to make it simpler. Okay? Then kapag halimbawa maliliit naman, we have milli, micro, and nano. So pag 10 negative 3 milli, 10 negative 6 micro, and 10 negative 9 nano. Okay? So may note siya dito. Doon sa mga base unit natin na inano kanina, diniscuss, si kilogram lang yung merong prefix na agad, no? Okay? Kasi yun yung ginagamit talaga. Okay? A kilogram is the only base unit that is defined with a prefix. Okay? So, I hope malinaw yung sa prefix. Rules for use natin. So, ilan lang sa mga kailangan natin tandaan. Quantities defined by several units which are multiples of one another are separated by a dot to avoid confusion ng prefix natin, no? So, na-separate daw siya by dot, no? So, halimbawa, ang gusto nating sabihin is meter per second, no? Meter second ang gusto nating sabihin. Okay? Kung meter second ang gusto nating sabihin, dapat ang unit, ang ating symbol sa kanya ay meter second at hindi ms. Okay? So, anong kaibahan nito? Ito yung tinatawag nating meter second kasi represented siya by a dot kasi siya ay 2 units siya, no? And itong isang ito, siya ay may prefix na m, which is millisecond. No? Kaya be careful with that. Okay? Minsan, ang ginagamit, dash, no? Halimbawa, millisecond, ganyan. Kaya foot second. Pero kung wala, baka ma-misinterpret natin as prefix para dun sa base unit natin. Next, the exponential power on a unit having a prefix refers to both the unit and its prefix, no? So, halimbawa, nakita ninyo si kilonewton, okay? Si kilonewton is may squared siya dito, okay? Kung may prefix kang kilonewton, ibig sabihin din ito is kilonewton squared. So, kasama sa square yung mismong prefix natin. Okay? So, dapat kasama yun sa representation niya. Number 3, with the exception of the base unit, the kilogram, in general, avoid the use of a prefix in a denominator of composite units. Okay? So, kung halimbawa, meron kang mga meron tayong unit, no? Halimbawa, meron tayong Newton per mm. Okay? Halimbawa, yan yung unit natin. Mapansin nyo, yung denominator natin is naka-prefix siya na milli. Okay? So, to change that into, kasi sabi nito in general, avoid use of prefix in the denominator. So, paano natin i-change yan? Si milli is equivalent sa 1 Newton all over 10 negative 3 meters, no? So, to change that, pwede natin gawin is to multiply natin ng 1,000 sa numerator at denominator. Mangyayari sa kanya is 10 cube Newton all over meter, no? Ano ba si 10 cube? Again, sa prefix natin, siya ay equivalent sa kilo. So, Newton mm is equivalent to kilonewton per meter. Okay? So, naging base unit na yung denominator natin. So, na-avoid natin yung prefix sa denominator. So, hindi lagi siyang applicable pero if pwedeng iwasan natin. Okay? So, lastly, when performing calculation, represent the numbers in terms of their base or derived units by converting all prefixes to powers of 10. Okay? So the powers, the final result should be then expressed using a single prefix. Also, after calculation, it is best to keep numerical values between 0.1 and 1,000. Otherwise, a suitable prefix should be chosen. Okay? So, halimbawa, mayroon kayong problem na pinapamultiply sa inyo is 50 kilonewton multiplied by 60 nanometer, no? So, paano mo multiply yan? Sabi niya, i-change mo muna yung prefix natin into powers of 10. So, si kilonewton is 50 times 10 cube n. Si nano is 60 times 10 negative 9 meters. Okay? Pag pinerform mo ngayon sa calcu yan, 50 times 3 multiplied by 60 times negative 9, that is equivalent to 3 times 10 negative 3. Then ang unit natin is Newton meter. Okay? So ano ang negative 3 sa ating prefixes? That is milli.
Milli po.
So this will be 3 milli-Newton meter. Okay? So ganun yung paggamit ng number 4 na step natin. Okay. Change mo muna sa powers of 10 yung lahat ng mga prefixes. And then after multiplying them, you decide kung ano yung prefix na applicable dun sa system. Okay? So, yan. So, ayan. Before we proceed dun sa conversion examples, no? Some more details regarding sa calculation natin. So, pag nag-numerical calculations tayo. So, numerical work in engineering practice is most often performed by using handheld calculators and computers. Kaya important na yung problem natin be reported with both justifiable accuracy and appropriate significant figures, no? So, baka may nalilito pa din sa pag-identify kung how many significant figures a number has. Okay? So yung first natin is yung tinatawag natin dimensional homogeneity. Ang ibig sabihin lang niya, pag kakalculate tayo o magsosolve tayo, make sure na we express yung lahat ng units natin ng same units. Okay? So, if ever sa formula or sa, halimbawa sa, yung ginagawa nga doon sa rule number 4, before tayo nag-multiply, in-enlist muna natin yung mga prefixes niya para hindi tayo malito, no? Kasi baka mamaya maglagay kayo ng squared dun sa mga prefixes natin. And also, yung homogeneity natin, kung halimbawa sa formula, katulad dun sa F is equals to mass times acceleration, no? Hindi na natin pwede baguhin si kilogram meter per second squared. Pero kung hindi pa siya nakaganong form, kailangan gawin mo muna siya dun sa base unit niya before you can continue, or gawin mo muna siyang homogeneous bago mo siya isolve. Okay? So, number 2 is yung significant figures na tinatawag natin. So, the number of significant figures contained in any number determines the accuracy of the number. So, ito yung simple rule para sa significant figures. So, leading zeros o yung zeros before ng any zero non-digit number are always not significant. No? So, hindi yan sinasama sa significant figures. A zero between a non-zero digit, lagi yung significant, kasama yan sa bilang. Kapag siya ay yung zero is nasa hulihan ng mga o nasa after ng non-zero digit, trailing zero, may dalawa siyang case. Kapag wala siyang decimal point, hindi siya kasama sa bilang. Pag meron siyang decimal point, kasama siya sa bilang. So let's have some examples to demonstrate that, no? Para hindi kayo nalilito sa significant figures. Kasi this is a basic knowledge dapat, no? Na I know naman marami pa din nalilito. No? Kahit ako nung college, litong-lito ako dito. So let's have our first example. Bawa, 10,082. How many significant digits? Tinatanong yung significant digits. So, mapapansin niyo yung 0 is between ng non-zero digits. So, meron tayong 5 significant digits, no? Or significant figures. Okay? Number 2. Kapag halimbawa 70,000, how many significant digits?
1 po.
Okay? How about the others? Tama ba? 1?
5 po.
5. So, again, pag walang decimal point dito, hindi siya significant. Okay? Yung mga zeros natin, hindi siya significant. So, tama yung answer kanina ni, I think Mr. Rieger nag-answer, no? So, 1 significant figure lang siya. Okay? About this one, number 3. 0.0025. How many significant figures?
2.
4 po.
4
po, sir.
So, the correct answer is 2 significant figure lang. Bakit? Si 0 sa unahan ni 2 are all leading zeros. All leading zeros are not significant. Okay? So, kaya ito lang yung significant natin, si 2 at si 5. Okay? Yung sinasabi ko dito mga 0, sila yung 0 after ng non-zero digit. Yung mga trailing zeros natin. Na ang condition niya, once na nagkamero ka ng decimal dito, tsaka mo lang siya masasabing significant. Pag wala siyang decimal place, not significant siya. Yes, Mr. Peregrine.
Sir, pag halimbawa po ba is nag-start yung number A sa 1 tapos 00 na yung kasunod, ibig sabihin counted po ba yun na significance?
1.00. So since may decimal point, kasama siya sa significant.
Thank you po, sir.
Okay. Okay, sige, let's try number 4. So 0.000309. How many?
3 po, sir.
3 po.
3 po.
3 po.
Okay. 3 significant figures. Correct. Number 5. Bawa 50010.000. How many?
5 po.
8 po.
5 po. 8 po, sir.
8.
Okay.
Eight ba,
So ito
sir?
yung question kanina, no? So this is 8 significant figures, no? Kasi meron tayong decimal point, no? Ito yung after nung basta magka-decimal any place, basta may decimal point, kahit hindi dito, no? Basta may decimal point after nung non-zero, significant na siya. Okay? So last, 0.004030. How many?
5.
5 po.
4.
2 po.
4 po.
4.
5 po.
So the correct answer is 5 significant figures. Bakit? Si 00 is a leading zero, so hindi siya kasama. Itong dalawa is in between, so kasama siya. Si 0, trailing 0 siya, pero kung papansin mo, may decimal point dito. So kasama siya as significant. So ibig sabihin, ito yung significant figures natin. Okay? So 5 significant figures. So ayan, dapat aware tayo dun sa significant.
Sir, basta po meron.
Alin? Sige, continue mo, Mr. Cortez.
Pag meron po ng that po, counted po yung trailing 0.
Yes.
Okay po.
Sir, may tanong po ako.
Yes, Mr. Diego.
May maximum po ba yung yung limit ng 0? Like 1 point plus 1 point plus 6 na 0?
Depende sa hinihingi sa problem, no? Pero usually kasi, bawa, nire-require ng problem, i-round off nyo sa 3 significant figures, yung pinaka-final answer. So, depende kung ilan yung 3 significant figures. Kung halimbawa, ang answer mo is, halimbawa, is 25.0054, no? Tapos ang gusto niya is 2 significant digit lang yung kailangan mo. So, kung 2 significant digit ka lang, ito lang yung i-answer mo, 25 lang alone. Depende, halimbawa, ginawa niya, ang requirement niya is 4 significant digits. So ito yon, 4 significant digits. Eh since yung itong digit na to is greater than 5, no? So dapat 25.01 yung magiging sagot mo.
Eh ano po, pagbibilangin lang. 7 po yun, like
Pag bibilangin lang,
1.00000.
medyo ambiguous kasi yung tanong mo kung bibilangin mo lang siya. Kasi ang tanong mo is yung limit ng bilang ng significant figures, tama ba?
Abo, pag
Kung
0 lang.
how the numbers are presented to you, doon ka na lang mag-refer. No?
Okay po, sir.
Tapos depende na lang yung sa operations. Minsan kasi, di ba, halimbawa, multiplication yung natin. Halimbawa, nag-multiply ka ng 5.4 times 5.55. Okay? Ang ruling, ang significant figures mo dapat mag-refer ka kung ilan yung magiging sagot mo. Teka lang. Pag minultiply natin sa calculator, ang sagot niya ay 297. Sakto. No? Pero ang kailangan mo is kung ano yung list ng significant figures dito sa dalawa. Ang list dito ay ito. Kailangan 2 significant digit. Okay? So kung 2 significant digit yung hinahanap natin, dapat yung answer mo dito should be 30. 3.0. Ano ba? 5.4 times 5.55. Sorry pala. Mali pala yung aking multiply. Ayan, 20. Kaya pala ako nalito. So, ito ay 29.97. Ayan. So, ito yung list mo. So, dapat ang answer mo na susundin ay 2 significant figures. So, dapat 2 significant lang. So, ito lang yung number na yon. So, dapat ang final answer mo should be 30 lang. Kahit hindi siya sabihin sa problem. No? Ilan lang yung sa ruling ng significant figures. Sa division, ganun din. Kung alin yung mas maliit ang significant figures, yun yung sinusunod. Pag sa addition, subtraction, ganun din. Kung alin yung pinaka-konti, yun yung sinusunod. Okay? Ano pa ba? Next is yung ating rounding of numbers. Okay? So, rounding of numbers is necessary so that the accuracy of the result will be the same as that of the problem data. As a general rule, any numerical figure ending in 5 or greater is rounded up and number less than 5 is rounded down. Okay? So, siguro malinaw naman to, no? Basta ending in 5 or greater. So, 5 or greater, mag-round up ka na, no? Pag less than, round down ka na. Okay? Number 4, calculation. So when a sequence of calculation is performed, it is best to store the intermediate result. So wag ka na muna mag-ground off kapag nagka-calculate ka pa sa calculator, no? Pwedeng as is na kompletong digits muna. Kung halimbawa, compose siya ng ilang significant figures sa calcu, gamitin mo lang siya as is kung hindi pa siya yung pinaka-final result. Basta sa pinaka-final result, i-consider mo is yung kung ano yung nasa choices, no? Halimbawa ay 3 significant digits yung nasa choices, i-select mo lang yung kaparehas na makukuha mo doon sa final answer sa kanya. Okay? Ano pa ba before we proceed sa mga example? We have yung general procedure for analysis. So this is when we tackle yung mga iba't ibang problems na, no? So the most effective way of learning principle in engineering mechanics is to solve problems. Talagang ano siya, no? More on muscle memory din, on how you practice your solving skills. So to be successful at this, it is important to always represent your work in logical and orderly manner, as suggested by the following sequence of steps. So first is read the problem carefully and try to correlate the actual physical situation with the theory studied. So depende sa topic na discussed. What happened? Okay, kala ko nawala. Okay. Next is tabulate daw natin yung problem data and draw any necessary diagram o mga free body diagram. Yung mga particle natin, yung free body diagram, no? So apply the relevant principles or formula that you can use when writing any of the equations. Be sure that they are dimensionally homogeneous, no? Dapat pare-pareha siya or pwede siyang gamitin. Pwede siyang mapag-multiply. Okay? Solve the necessary equations and report the answer with no more than 3 significant figures. So, general ruling lang to, ha? Okay, so and then study the answer with technical judgment and common sense to determine whether or not it seems reasonable. Yes. Para sigan, yes. Okay, baka napindot lang. Okay, so let's have conversion problems, no? To practice your skill in conversion, no? Para ito yung para sa basic concept natin. So we have 2 kilometers per hour. Convert natin to meters per second. Okay? And then paano natin siya i-convert to feet per second? Okay? So ilan bang meters meron sa 1 kilometer? No? So
1,000.
1 meter is 1,000 meter, no? And sa 1 hour, ilang seconds? 60. So meron tayong 60 minutes, no? So 1 hour. And sa 1 minute, meron tayong 60 seconds, no? So pag gusto natin makuha si equivalent ni 1 hour, gawin lang natin to, 1 minute, 60 seconds, no? Cancel to. That will be 3,600 seconds. Meron tayo sa 1 hour, no? So kailangan natin 2 kilometers per hour. Kailangan natin siyang i-change sa meter per second. So gagawin natin, alisin mo natin sa kilometer. So ito yung conversion natin. So lalagay lang natin sa ilalim para mag-cancel out as 1,000 meter. So cancel to. So okay na yung kailangan nating meter. Tapos seconds yung kailangan natin. So kailangan sa taas para mag-cancel out yung hour sa ilalim, kailangan ilagay natin si hour sa taas, no? So 1 hour o 3,000 seconds. Okay? So cancel to. Matitira ngayon na unit natin is meter per second. Okay? So pag inano natin sa calc yan, that is 2 times 1,000 all over 3,600. That is 0.556 meters per second. Okay? Delay pala yung sulat. Sorry. Ayan. Okay, I hope marunong mong pumindot sa calc yun, no? Tapos, ilan naman daw to in feet per second squared? Okay, so dito sa conversion natin na meron tayo is from meters, no, to feet. So pwede natin gamitin to. So ko-convert lang natin si 0.556 meter per second. Gamitin natin yung conversion dun sa table. So kailangan natin ng meter sa ilalim para matanggal yung nasa taas. So 0.3048 meters multiplied by 1 feet sa taas. Okay? Pag kinancel natin yung unit, matitira is feet per second, which is yung hinahanap natin. So, 0.556, divide lang natin by 0.3048. And we have 1.82 feet per second. Okay? So, this is our answer. And this is also our answer. Okay? Question dito?
Isa pa nga po, sir.
Okay? Sige, ibang problem naman para gumana yung ating ano. Okay? So, yan. Halimbawa, meron tayong convert down na natin yung quantity na 300 pound second, no? And 52 slug per cubic feet to appropriate SI unit. So, gagawin lang natin SI, no? May given tayo ulit na table. So, yung una, sabi natin, meron siyang 300 pound second, no? So, si pound para maging, para maging siyang SI, ito yun, from pound, multiply mo daw siya ng 4.448. Okay? So, gusto mo maalis yung si pound dun dito sa number mo. So, para maalis siya, kailangan mag-divide ka ng pound din sa ilalim para mag-cancel siya. Kasi ganoon naman di ba tayo sa number? Pag may parehas na unit, pwede natin i-cancel yung taas at yung baba. Okay? So, dito, meron tayong 1 pound is equals to 4.448. So, 1 pound is equals to 4.448 newtons. Okay? So, pag natin yan, that is 300 times 4.448. Anong nangyari dun sa pounds? Nag-cancel na yan. So, ang unit natin ngayon is 1334.4 Newton seconds. Okay? Pero, hindi pa 3 significant digits to, no? So, paano natin mati-change into 3 significant digit to? Pwede natin i-change o lagyan ng prefix siya. Okay? So, ano pwede natin ilagay na prefix? So, ito yung isang technique na siguro i-share ko na lang din. Meron tayong scale dito. Ito yung base unit natin. Tapos, lagay ko lang dito. Ito yung base unit natin. Tapos ito ay DCM K mga ba to? KHD. Okay? So, halimbawa ito yung base unit natin. Bawa, Newton. Dito yung Newton natin. Gusto natin siyang gawing kilonewton. May K, may kilo. This is kilo, heka, deka, deci, centi, tsaka mili. Okay? So, pwede nyo din naman gamitin to, pero ako lang ginagamit ko to dati. Kapag nabawa in newtons ako, ito yung base unit ko. Para maging kilonewton, mag-move yung decimal ko ng 1, 2, 3. So, from dito na siyang 1.3344 kilonewton second. Pero kailangan ko ay 3 significant digit lang, 1.33 kilonewton second. Okay? Again, from base unit, yung pinaka-newton lang natin. So, pag gusto ko naman siyang gawing milionewton, mag-move ako ng tatlo ulit. No? 2 unit. So, a little guide kung gusto kong medyo nahihirapan. Pero dito, again, dito para maging ma-represent natin as kilonewton, diba si kilonewton is 10 raised to 3. No? Kung 10 raised to 3, mag-move tayo ng tatlo pakaliwa. No? So, ganun din. Ito din yung lalabas na answer and this will be our final answer. Okay? Ito pa din yung final answer natin. Okay? Yung isa naman, slug per cubic feet. No? So, dun sa unit natin, so meron tayong 52 slug per cubic feet. Gusto na natin siyang i-change into SI unit. No? So, si slug muna. So, slug tsaka kilogram. So, para mawala si slug dun sa taas, kailangan si slug ay nasa baba dun sa conversion natin. So, 1 slug is 14.59 kilograms. Okay? So, pag kinancel natin yan, magiging kilograms na lang siya. Ngayon, yung feet natin dito, kailangan maging SI din siya. So, dito yung feet, meter yung equivalent niya. No? So, kailangan, para mawala si feet dun sa baba, kailangan may feet sa taas. Then, mayroong meters dun sa baba. 3048 meters. Pero wag mo agad i-perform kasi naka-cube siya dito. no? Kailangan mo is tatlong set na ganito. Okay? So, pwede mong gawin, lagyan mo na lang ng cube doon. Para maging, pag yan na, pag inano yan, magiging cubic feet over 0.3048 cube meter cube. So, magiging cube ka na. So, pwede mo na i-cancel yung tatlo. Okay? So, pag kinalki mo to ngayon, magkano to? 52 times 14.59 times 1 over 0.3048. Tapos naka-cube siya. We have 26792.53135. Ito yung kompleto sa calcu. Kilogram per cubic meter. No? So, pwede natin i-change yan. So, naka-kilogram tayo. Okay? So, kilo, kung gusto natin gawing 3 decimal place at 3 significant figures lang, kailangan ito yung matira natin, di ba? So, dapat dito yung movement natin. So, 1, 2, 3, 4. So, hindi pwede dito. So, dapat dito na lang. So, kasunod ng kilo ay mega. Okay? So pwede mong i-extend tong number system natin. Ito yung base unit natin na Newton, deci, heka, kilo, 2, 3, 1, 2, 3. So, ito yung ating giga, mega, then kilo. Okay? So, ito yon. Nandito tayo sa kilo ngayon. Then 1, 2, 3, magiging siyang mega. So, dito, 1, 2, 3. So, magiging siyang 26 point. Kailangan ko yung 3 significant. So, gawin ko na itong 8 mega gram per cubic meter. So, this will be our final answer dito. Okay? Question? Okay, next. Yan. Represent each of the following combinations of unit into correct SI form. So, yung number 1 natin, letter A, megagrams over milliseconds. Okay? So, gagawin lang natin, change lang natin into power of 10 yung ating mga prefixes. So, we have 10 cube kilograms, no? Tapos over 10 minus 3 seconds. So magka-cancel out lang yan dalawang mag-aano yan, magiging siyang 10 3 minus 3 sa loob ng exponent kilogram per second or 10 raised to 6 kilogram per second. Ang 10 raised to 6 ay equivalent sa gigagram per second. Okay? Next, letter B, yung Newton mm natin. So this is okay na earlier, no? So 1 Newton all over 10 negative 3 meters. And then, ginawa natin is, since ito is negative 3, magiging siyang 10 cube Newton per meter. That is kilonewton per meter. Okay? Letter C natin is millinewton all over kilogram multiplied by microsecond. Okay? So, millinewton is 10 negative 3 Newton all over kilogram times 10 negative 9 seconds. Okay? So, pag inano natin yung units, so that is 10 negative 3 minus 9 Newton per kilogram second. So, magiging siyang 10 raised to 6 Newton kilogram seconds. So 10 raised to 6 is actually mega Newton all over kilogram seconds. Or teka lang. Micro, let's check nga lang. Baka mali ako sa micro. 6 or... micro pala is 6 lang, no? Nano pala yung 9. Micro is 6. So, dito, dapat siya ay 6 lang. So, minus 6, 6. So, this should be 3. So, hindi siya mega. siya ay kilonewton, kilogram, second. Okay? So itong last part, siguro as practice nyo na lang to, no? Convert nyo lang to its appropriate SI unit. So, yeah. I-check nyo kung makukuha nyo yung answer. Okay? So, practice nyo na lang sa sarili nyo to. Okay? So, pero so far, question regarding our topic. This ends our lecture for today. The basic concept and introduction and principle, basic principle for mechanics.
Sir, available po yung file nun. Sir, bibigay niyo po sa amin.
Yes, i-upload ko lahat to sa Neo LMS mamaya.
Salamat po.
Okay? Kahit yung may sulat, may annotated file, yes, ibibigay ko po. Okay? So kung no more question, okay, before we go